Okay, let's assume that you want to configure a counter for your program. You have to choose the type of counter which is appropriate for your program. If you need op counter, you have to use CTU instruction. CTU instruction is an op counter in Allen Bradley PLC. And if you want to have a down counter, then you have to use a CTD. So CTD is counter down, CTU is counter up. So depends on which one you need for your program. You have to use the appropriate instruction, and then you have to use your counter number. Normally we start from the first one and we choose the one that is available after that. And finally, you have to set your preset value for the total number of count. The next thing I want to discuss is how to address the counter registers. So let's assume that somewhere in your program you need to address to the preset value of a specific counter. So first you have to describe which counter you want to address. So the counter addressing is going to be C5 colon the counter number. Let's assume that I want to address to counter 4. So this is counter 4 up to here. If I want to address to the accumulator value, I have to use .acc. If I want to address to preset value of the same counter, then I have to describe the counter number first, and then I have to use PRE, which is addressing to the preset value of this particular counter. I want to remind you here that whenever you have dot something, it means that you are addressing to a word. And if you have forward slash something, then it means that you're addressing to a bit value. Now let's focus on different bits that can be used in order to refer to the condition of the counter. But before doing that, I want to describe in these bits for different type of counters. So it depends if you are using a CTD or CTU. This is an up counter, this is a down counter. So we have 5 different bits, but only 3 of them are related to each one of these 2 counter. So if we are focusing on a CTU, then we are going to have CU, DN, and finally OV. If you're focusing on a down counter, we are going to have CD, we are going to have DN, and finally we are going to have UN. What are these? So CD and CU stands for count down and count up enable bit. Done is similar to what we have for timers, that's our done bit, and UN and OV shows you if you're having underflow or overflow. CU and CD are very much similar to enable bit of timer. So these 2 are true if the input wrong of your counter is true, and they are going to be false if the input wrong is false. The done bit is also similar to what we have for the counter. Let me write this here. So these are similar to the enable bit of timer. The done bit is also similar to what we have for timers. So it's going to be equal to 1 as soon as your accumulator value reaches to your preset value. Now let's see when the underflow and overflow bit will trigger. In order to show you that, I want you to look at this picture here. Here you can see the range that we are allowed to have for our preset value and accumulator value. So it can be anywhere from minus 32,768 up to 32,767. So by default, your accumulator value at the beginning is equal to 0. If you're having a CTU, which means that you're having a counter up, then your accumulator value start accumulating by incrementing the accumulator until it reaches to your preset value. Let's assume that here is your preset value. As soon as it reaches to your preset value, your done bit will turn to 1. But remember that when your accumulator value reaches to your preset, it doesn't mean that it will reset your accumulator back to 0. But your accumulator continue accumulating and incrementing. So still it will go forward and it will be increased until it reaches to your maximum possible positive number. At this point, you're going to have an overflow. So the next number that your accumulator will show after 32,767 is going to be minus 32,768. So at this point, an overflow bit will be true. So OV will be true in order to show you that you have reached the maximum possible number, positive number, which is possible for your accumulator. So let me show you what exactly happened here. Let's assume that your accumulator is equal to 32,766. The next time that it will see a transition from false to true, your accumulator will change to 32,767. The next time that it detects a transition from 0 to 1, it will change, it will incrementing by 1, means going back to the minimum number that you have, or the maximum negative number. So it will change it to minus 32,768. That's how it works. We have the same thing for underflow bit. So if you are having a countdown timer, then it will start incrementing until it reaches to your preset value. Let's assume that this is your preset value. So at this point, your done bit will turn to 1. However, your counter won't be reset to 0. Let me tell you what is the reason. The reason is that your counters are retentive instruction. So it means that because they are using retentive memory, they won't be reset back to 0 whenever the accumulator value reaches to your preset. So in order to reset your value back to 0, you need to use a reset function. And this reset function needs to have the address of your counter. For example, C54. So whenever you use this reset function, which is an output function, then you can reset your timer number 4. Okay, back to what we were discussing here. So if you increase your accumulator value, at some point it will reach to your preset and the done bit will be activated, but it doesn't mean that it will be reset back to 0. So it will continue accumulating, or in another word, incrementing. At some point, your down counter will reaches to the maximum negative number that you can have in your 16-bit digit for your accumulator value. At this point, the next transition will bring your accumulator into this number. So let's assume that your accumulator was at minus 32,767. The next transition means that the accumulator will be at minus 32,768. 768, and as soon as the counter sees another transition from 0 to 1, it will change the value to positive 32,767, and at this point the underflow bit will be equal to 1. So this underflow bit shows you that you have reached the maximum negative number that is possible to save in your counter file. In this table, you can see the detail about your counter bits. So it's telling you that your counter enable bit is true when your counter wrong is true, and it's false if your counter wrong is false. Then you have counter overflow, and whenever your accumulated value wraps around your maximum positive number to maximum negative value, it will turn the overflow bit or underflow bit in the other scenario, in this scenario, into 1. And then you have your counter done bit. For both of them, it means that your accumulated value is equal or greater than your preset value. So whenever your accumulator reaches your preset, and any time after that, which means that your accumulator is greater than your preset, your done bit will be equal to 1. Now let's take a look at different bits here. So similar to what we discussed for timers, every structure for counter has 3 words. Word 0, word 1, and word 2. Word 1 is being used for preset value, and word 2 will be used for your accumulator value. In word 0, we are using the most significant bits to describe the bits related to the counter, so you can see them here. So in word 0, bit 11 is showing the underflow bit, bit 12 is showing the overflow, bit 13 is showing the done bit, 14 is your CD, and 15 is your CU. So if you're using, for example, a CTU, then the bits that you're basically using are CU, done bit, and overflow. And if you are using, let me use another color here. If you are using a CTD, then it means that the bits that you are using are CD, done bit, and underflow. Now I want to